Section 1, Sounds of Vibrating Strings, where we'll investigate the properties of a vibrating string and how it affects the sound that's produced when it vibrates. We have a pulley with a mass on the end, a string that stretches across the table that's attached at one end down by me, and a little styrofoam cup that we will use to help amplify the sound. We also have a meter stick here that we're going to use to measure the length of the string. As you can see from the setup, we've got a cup here with a string across it. The purpose of the cup is just to amplify the sound made by the string a little bit so you can hear it a little bit more clearly. You'll notice that if I come down here and if I just take the string and I snap it a little bit, you get a sound that's produced by the vibrating string, which causes the cup to vibrate, which amplifies the sound just a little bit for you. For the first part of this activity, what we want to do is see what effect the length of the string from the cup over to the fixed end over here has to do with the pitch that's being provided by the string as it vibrates. So we'll start out with the cup in the beginning position here, and you can see as we go along the meter stick that down to the end of the fixed end here, it is 80 centimeters for the first position. So record 80 centimeters in your log. Also record the fact that we have a 500-gram mass hanging on the end of the string over there to provide the tension. So this is the sound you heard before. That's at 80 centimeters. All you want to do now is qualitatively get a feel for what the sound is like. In other words, is it low, medium, high pitch? 3A, record your observations in your log in a table similar to the one that is shown in your text. We're going to move the cup in so the length now is 60 centimeters. If I pull the meter stick back, now you can see it says just about 60 centimeters. Again, if I strum the string, that should sound a little bit higher to you. Bring the cup back further, so there's now about 40 centimeters. Keep in mind that the tension in the string is always staying the same. The tension is provided by the weight on the end there. You can see that this now says about 40 centimeters to the end of the string. And once again, strumming the string so we can hear it. And you probably will notice that it sounds higher than it did at the 60. For our last position, we're going to bring the cup into a length of 20 centimeters. And we're going to turn the meter stick around to do this. And we're going to measure it from the opposite ends, from 100 down to 80. So the string length now is just about 20 centimeters. And if we listen for the last time, once more, you probably notice that that sounds quite a bit higher. So now we have 4 different positions for string lengths, and what you should have seen is that as the string length got shorter between the fixed end and the cup, that the pitch that was put out, the frequency of the sound being generated by the string and amplified by the cup, went to higher and higher frequencies. 4A, record the different lengths of the vibrating string and the relative pitches of the sound in the table in your log. 4B, make a general statement about what happens to the pitch you hear as you change the length of the vibrating string. For the second part, we're going to change the amount of tension that's in the string, and we're going to see what effect that has on the pitch that you hear. 5A, make up a new table and record your data in the log. 5B, Describe the sound you hear when you pluck the string with the 500-gram mass on the hanger. We'll choose an arbitrary length for the string, so we'll say about 50 centimeters, which is one we didn't use before. And we're going to start out now with a pitch, see, at 50 centimeters, and this will always remain the same. Right, and then we're going to vary the tension in the string. Just strumming the string here with the 500 grams on the tension in the string, 500 grams in the string, we get a sound that sounds something like that. We're going to hang progressively larger masses on the end of the string and thus increase the tension. We'll be doubling the tension by adding another 500 gram mass. You probably notice that the pitch sounds a little bit higher. And now we're going to increase it once again to 750. We have another mass on here, so now we have a total of 1,500 grams. Drumming the string once more. It clearly sounds much higher to you. And finally, we're going to put the last mass on, making the total tension of the string provided by the masses to be 2,000 grams for a tension of almost 20 newtons. Once again. Six A, describe the sounds made by adding masses to the string. Six B, look over your data. Increasing the mass tightens the string and increases its tension. Make a general statement about what happens to the pitch as you change the tension in the string.